So, good afternoon. Welcome to our OpenStack storage session. I hope that the temperature will be better than the other sessions, but it's good because it's more summit setup, which is I really like. To those of you who actually were at the Hong Kong summit of Ice House, some of the design sessions basically were kind of this crowded, and I do encourage to have a Q&A session. So feel free to ask questions.
The weather in general is hot and humid.
Oh yeah, just like here. So the setup is perfect. We have, if someone is called, we have a lot of clothes here. So let me quickly just tell you who I am and what I do, and then we'll dive deep into storage. So I'm working for Red Hat as a product manager. Focused on cloud storage, OpenStack specifically, and if we open up storage in OpenStack, it's more than one project. So in a sense, I had to be able to capture Cinder, that we heard before about the replication needs, and Swift, all of them into one slide deck, and capturing what's new in Havana, basically, right? So for those of you who haven't looked at the release notes for Havana, looking at what's new in storage, it's a good start, but you won't find everything there. And it has to do with how we operate in basically the community. OpenStack, how many of you looked at the blueprint before? Yeah. How deep are the blueprints, right? So some of the blueprints in OpenStack are one line, right? So it's hard for us to basically to know what's in there until we actually take it to the test run and find out, right? So what I'll try to do is shed a bit of more light what's new in OpenStack, and given the fact that we're progressing every 6 months, this is incredible. So whatever you're going to see today was done in 6 months. This is rocket science, purely. And the only reason we can achieve so much is the fact that this is one of the larger open source projects on planet Earth. And I think this is tremendous. And most of us comes from companies or our own companies, and some of us are developers, so we can evaluate how long does it take to introduce a feature and look at the scope of what we have accomplished in 6 months. It's groundbreaking. So without further ado, let's just look at who we are in terms of Red Hat. So for those of you who attended the keynote sessions in the morning, you heard that we're basically the top one contributor for a while. But before we even look at OpenStack specifically, let's look at what the company does. So how many of you use Linux today? All right. So we were there like 20 years ago. And what have Red Hat done into Linux is actually be able to take an open source project and bring it to the enterprise. And enterprise that was like dominated by Unix the other days, Windows, etc. And I think we changed the landscape since then. And we were at the revolution point back then. And in a sense, everything we do, if you want to keep takeaway from this presentation in terms of Red Hat, is everything we do is upstream. We are a pure open source company. There's not a single line that we do which is proprietary. And every project you'll see that we are giving support to as an enterprise edition has an upstream version. For RHEL, it's Fedora, middleware, JBoss, Object for Rev, Gluster for Red Hat Storage, RDO for OpenStack, which is a community edition. All the innovation we're doing, we're basically doing it first upstream and then to a downstream version, which is hardware and support for enterprise customers.
What RDO?
RDO? I don't know, but it's a cool name. It has to do with distribution and Red Hat and OpenStack. So thank you for asking that question. So if we look at the differences, what we do is basically take, as I said, a community project and bring it to the enterprise. And if you look here, we have OpenStack the vanilla, which is the community edition. Then we basically take that edition, we do a lot of innovation there, and we then do a backport to the enterprise platform. How many of you know how long do we support RHEL, the enterprise Linux?
5 years.
Yes?
I don't know.
10 years.
7 to 10.
10 years support for Linux. This is crazy, right? So think in your head, what would it take for us to be able to support something, right? So it means that you really have to maintain the code. You have to know the code in order to give such long level support. And I mentioned earlier that OpenStack is every 6 months we have a new baby, right? A new release. And right now in Havana we already increased our release from 12 to 18 months. Going forward, every release of OpenStack will plan to increase that. So it will be 24 going forward. So already we can give ahead 2 years ahead in advance support for the distribution, which is important stuff. This is what makes us enterprise, because someone needs to support it. How many of you have rolled OpenStack in production? Some of you I know, at least one. And how much of coding you have to do just to get there? Going forward, would you like to keep doing that, or would you like someone else to do it for you? Backport to the mainframe, etc. So this is what changed from a vanilla, say, to an enterprise distribution that actually could be leveraged. Another key area is certifications that we'll talk about later, because someone has to make sure that all the components, OpenStack doesn't do anything on its own. It's a manager of managers. In a sense, it's a pluggable infrastructure. We can connect network devices, storage devices, etc. Someone needs to make sure it all works together, right? And we've done it to Linux. We're doing that again to OpenStack. Yes?
How long are you lagging behind
2 months.
vanilla? 2 months?
2 months. And we have, that's the minimum, because it's like, as I said, 6 months. We have to invest in testing, hardening, security to make it enterprise, right? That's the minimum, I think.
On the previous slide, it was Gluster is also backed up by Red Hat.
Yes. So Gluster was acquired by Red Hat a couple of years ago, and we have done with, of course, everything we do is open source. KVM, for example, that started from Kubernetes, an Israeli acquisition, right? Became an open source. It's the building blocks for Red, actually, the enterprise virtualization. So what does it mean to be top contributor? So it's not just the lines of code and how talented our developers are. This is, as I said, if you have, how many of you own a car? Your own car. If your car gets broke, and I'm not just talking about some mechanic level, all the cars has today computers, right? If your computer car gets broken for some reason, the brakes doesn't work, whatever, who would you go to? Some guy on a shop on the way that may deal with it? No, you will go to the vendor that actually manufactured the code, because he knows the code better and gives you the support and reliability you're looking for, the warranty, if you will, right? In a sense, we're there. We're the number one, so in a sense, we know the code because a lot of it was written by us. This is how we can support it. That's our model, in a sense. And it's not just being able to write the code, it's where we write the code and how, the projects we involve. Just do like this. Pick a project in OpenStack today. You'll find a Red Hat code in there because we're contributing everywhere. We're contributing, and of course we're showing leadership because some of we just finished a disaster recovery service, right? Innovation projects that are missing. OpenStack is not mature enough. There's a lot of building blocks that we need to leverage to get it where it needs to be. Someone needs to drive forward. We took some of the responsibilities. Of course, it's an ecosystem effort, but we're part of it. Questions so far? Okay, let's dive into Havana. How many of you already rolled Havana? Brave man, brave man. Okay, so we talked about 2 months. This is like a few weeks after, right? About. Okay, so let's zoom into what's new in Havana. I'll give you there's a lot of content here. I would not go into deep dive into each one of them. I will highlight a few of them that are very important, right? Milestones. We'll start with Cinder, and then we'll work our way for Plan Swift. And at the end, I'll allocate like 5 minutes to talk about what's in the works for ISAMs, because we're already there. As to those of you who doesn't know, this is when things happen in ISAM right now. This is where our second milestone is actually, in terms of coding, is already being done. So we can give you already a glimpse of what's coming up. First one I actually placed is encrypted volumes. Now, some of you don't know encryption for every layers in life. We know encryption in networking, like you can do IPsec if you want to in networking. And volume encryption is important, storage encryption, because today we have Cinder. Cinder has an API to support backend storage, and the storage backend storage can provide encryption. Why do we need encryption in Cinder? Thoughts?
Multi-tenant?
Multi-tenancy, thank you. More. I'll give you a few examples from the news, and then it will just stimulate your brain. 2 months ago, I was in Europe visiting cloud providers. And all of them asked me the same question, and after a few meetings, the ball that actually I understood what we were talking about. This is exactly when Angela Merkel phone was like tapped by the NSA and all that. So if you recall that incident, so it depends that this type of events, global events, has impact on even cloud providers, because now with new regulations, the cloud providers doesn't want to, or even the country doesn't know where, doesn't want to basically place the data outside of the country because of regulations. Worried might be tapped, etc. Right? So if you go to the Amazon, which we look to reference, can you know exactly where your data is placed? How many are using Google today? Yeah. Email, music, photos. Can you tell me where your attachment or your photo is currently being tapped at? So that's one of the problems with cloud larger providers, because they cannot guarantee you that. So in a sense, OpenStack has the ability today, as you all know, you saw the cycles in the morning. Most of the adoption of OpenStack right now is in private clouds when it comes to enterprise, right? It used to be infrastructure providers. Now we're seeing a lot of private clouds, and this is exactly it. I need to be able to know where the data is. And it's not just I need to know where the data is. Some of it I want to expose. Because let's say I'm in a banking sector, I would like to take your bank records and maybe highlight only your credit card usage monthly to your mobile app, right? From a cloud software as a service or platform, right? So I'll need to be able to go and somehow extract the relevant data in a secure way. You mentioned multi-tenancy. As a provider, I might use basically serve different. There's the Coke and Pepsi, right? Coca-Cola and Pepsi. You all know that, right? On the same cloud. Just imagine that, right? So this is a big thing. Now, what's the protocol we're using in storage? Do you know most of it for management? What do we use? iSCSI. iSCSI as a network, SCSI, right? So if I'm not just the storage, but the way to the storage is exposed. If I'm a hacker running FREL or whatever, and I become the man in the middle, I'd be able to look at your data, right? So we need to protect the data not just in the storage side, but all the way to the storage. And this is exactly what the feature is. So we're actually being able to present a block device unencrypted, right? But actually at that host, virtualization host, encrypt the bytes before it written to the storage. That's a key element. This is the new era problems, because we're in the cloud, and with the cloud, we have new sets of problems. It's no longer my storage is in one block device, I can protect it. I need to be able to find this area that are not protected.
But to make application work, the key,
yes,
symmetric or asymmetric, should be stored in the cloud.
Perfect. So actually in this deployment, the key, I don't have it in, oh, I do have it. So the key management appliance is actually being deployed in the cloud to remote. So because you need to have the keys, right? One way for you to basically decommission, right, storage that was protected is basically delete the keys. Once you don't have the keys, you cannot unlock the box, right? So it's another.
But from the man in the middle, it's not a solution, because the man in the middle knows the key.
Not necessarily. So the key is in a place that it's not necessarily in the place that the network segment that they look for.
But it's a part of user management. There's a part of the keystone, or
no, underline.
Underline.
The user doesn't know.
The user doesn't know. This is ultra span to the user.
So it's key which is not changed by user.
No.
Not managed by user.
No. Think about the one good analogy may be, there's today self-encrypted disk, right?
So who,
similar thing.
So who owns the data? Data provider or the tenant?
The tenant. That's the
So key should be the tenant.
Tenant, administrator. There's a whole change from the user perspective. So it's not the user, it's the administrator for that matter.
So it's integrated with auditing.
Of course. Nobody's involved, as you can see, everything. So next, sorry, let me go back. Another important feature that was added, this is heavily was introduced by Red Hat, as the QM Assistant snapshot team. You heard it before to those of you who attended the disaster recovery on the replication side. And QM guest agent is one of the things, because if you take a snapshot, you need to be able to actually house the application in consistent state. QM GA, which is the guest agent, can support both Windows VSS and on Linux FS3, so you can actually, and you could utilize that if you take MySQL, hot backup mode, etc., etc. And this is something that was enabled by this feature. The key thing is some of the backend, like NFS and GlusterFS, doesn't support snapshots today yet. It's being on the roadmap, but using this functionality, they can now support it. Okay?
Even on storage level?
Yes. Storage is, as you know, Gluster implementation is based on commodity, right? It's a one-up level, but
Yeah, I mean, if I do snapshots on the lower level.
so no, it's not off level. It's not in that sense.
Okay.
So let's jump next.
It's forced to be encrypted?
What?
You are forced to encrypt it
No,
because
no, optional.
it have performance.
Optional.
How much does the encryption and decryption add to the latency?
Good question. Security has price, to those of you who doesn't know, but again, so some customers, if I mentioned banking, for example, if you don't have security...
It's near real time, real time.
It's real time.
Real time?
Every write and read you do, you have to encrypt it has a penalty. Centralized mount options, before that feature was introduced, you actually had to go and set all compute nodes separately. Now we have a one way to do it for NFS and GlusterFS. Let me just finish the slide. Extend the volume, I call it basic functionality, to be able to extend the volume, like resize. This is basic stuff that we're slowly bridging the gap on basic functionality. Yes?
So the last question regarding the encryption.
Yeah.
So because of all what we said previously, is it possible to make pluggable driver for encryption algorithm?
So it's already there. So it's not a encryption algorithm. Basically, since you already have the Cinder pluggable API, some of the vendors already bring to the table their encryption solution. So you can leverage, if you want to do all, I mean, we mentioned iSCSI, right? Some of the customers use iSCSI to that without even using CHAP, the authentication encryption, right? So you can do CHAP, mutual CHAP all the way. You can have encryption set in Cinder Nova, for that matter. You can have IPsec set, and of course on the storage side. It's not, it's layers. Security, if you haven't got into security yet, security is all about layers. We mentioned man in the middle can get one layer maybe. But our job is to make it. Because putting things in the cloud, security is a must, right? I don't have to tell you. Let's jump forward because we have a lot of covered ground. Quality of service is a big thing. It's another theme in Havana. We'll see two features around this. The other one, of course, is volume rigging. And basically, some of the vendors out there already support advanced quality of services. And if you zoom out, right? We're an Openstack user, for that matter. Just like today, you can go and use flavors, right? I can choose. I want to create a disk. I can choose a flavor, which is small, large. What if you would like to roll maybe a web server, right? And that web server will already have a policy or a quality of service configuration. So because we already know this web server needs that and that bandwidth, that and that maybe IOPS characteristic. From a user perspective, one of the things you can do is like, okay, I want this as a web server deployment. Automatically, I will have the setup boundaries this is the guaranteed boundary. I don't have to move things around in the cloud management. This is all about provisioning, deprovisioning from up to down. Again, not all the vendors support it. It's very key. Going forward, I do say that's one of the areas when this is all about. I want to do one click and then have everything be done all the way to the storage. Because the storage capabilities are already out there. In a sense, we're reflecting these capabilities in the OpenStack management. Volume host attaching, basically allowing to use specify host name. It's a small feature, but it's important. Another volume, as you see, there's a lot of features around volumes management. Let me just complete this. changing the ownership. So we mentioned multi-tenancy. I would like to basically to take that PepsiCo volume and move it to Cohen, right? For example. Now I can actually be able to do it and support in one transfer command this operation. Okay, it's basic things, but we're not there before. This is why it's an important release. Yes?
Regarding the quality of service, is it possible to make a connectivity to the hypervisor
scheduler?
Right.
So I think if you ask me, quality of service should be top down, right? The storage, Cinder, of course, has to enable it, has to play in the game, but it has to come from above. We do have schedulers in Nova, and we do have, this is one of the things we're going to talk about soon, is the schedulers in Cinder, and even in HISOS, weights, for example, is one of these things. So good question, let's keep that in mind going forward. Volume migration, this is a great, another progress, right? To be able to actually migrate a volume to another host or entirely different backend. I'm using today Ceph or NetApp or whatever, right? Or even local storage. I want to decommission that, move to another backend. I want to move it to another host. I didn't have this ability before. I'm glad to have the guy who wrote the code in here. So anyone has a question for this, come see us later. This is another sub feature relates to this, to be able to hot swap the attached volumes transparently, right, to the instance. Quotas. Quotas are important. Quotas are there in, already in different areas in OpenStack. What we have basically done is actually, and by the way, quotas are not just from tenant point of view, but it can be all the way to the users, right? So we have two levels of quota management. What we basically added in the Havana release is to be able to set the default. One of the things that can happen with quota settings is the exhaustion. So if you're talking about quotas capacity, what happens with this capacity is, right? What notifications do we have, etc. So it's not enough to enable quota. There's all the management that comes with it. That's and we see that it's not just in Cinder, by the way. We also have quota management. You'll see featured in Glance when we get to Glance. Cinder backup. That's an important one. And again, backup was enabled first in Grizzly to Swift only. What we've done in Havana is basically extended that to any object storage, right? So Ceph supports that already in Havana today. Reddit storage roster will support it in the next release. And I think that's another important milestone. For those of you who look at the Amazon model, we mentioned disaster recovery earlier. The building blocks for disaster recovery is the ability to do backup. There's a whole notion of backup to cloud as well. We're not going to touch that as well. But this is basically backup to object storage, not just Swift. Scheduler hints. The most common one is the filter scheduler. And weights, this is basically are able to enforce different parameter based on, we're questioning the arrays, and we do selection. One of them is, of course, insufficient free space or insufficient capacity, etc. And to take better decisions. Right now, the model doesn't work 100% well because sometimes we not be able to choose the right or the relevant backend because the weight characteristics are not completely there. This is something in the works for ISOs as well. iSCSI over RDMA, it's basically better performance, almost 5 times better, drove by Mellanox. RODIS support, rate limit is another QA parameter that extracted in Cinder. I will basically close Cinder. This is basically on the Gluster FS support that became native. We saw the support for Snapshot includes clones as well as volume migration. New drivers, I think this you saw some of it already in other presentations today, so I'll just jump to this. This is things in the works for us in the Reddit OpenStack Enterprise Virtualization, Enterprise OpenStack, where we have a certification for vendors. This is some of the vendors we're currently being certifying for Havana. Havana release by Reddit is coming up in 2 weeks. As you remember, we have a bit of delay. This is a key partners that are already certified with Reddit today for OpenStack, as you can see, not just in storage. Okay, that's one of the strongest points of Red Hat being able to certify and make sure that everything works together. Glance. Important feature, multilocation. This is another step towards disaster recovery. The notion to be able to use an image in more than one location and actually point and get the relevant metadata from that location. So if I'm sitting in New York and there's an image in New Jersey, there's no point of me to pick up the image in New Jersey, right? So that's basic stuff, but we're not there before. Registry, of course, is a more backwards compatibility feature that was added. Quota, we talked about also in a sense of glance. Direct URL metadata is basically ease of use, I call it, because it allows you to see where exactly you place the data and not just a string that doesn't make sense. So, Swift, global cluster. That's one of the biggest features that was added in Havana. Also be, of course, as you know, Swift is already globally deployed today, and you can have globally replicated instance, and it supports tier zones, and there's a lot of enhancements was done in Swift, most of them around performance optimizations, and of course being able to segregate network for replication, etc., things like that. This I will jump. Thread pools is an important one. Basically, being able to use external real threads to manage better concurrent reads and writes. And there's a bunch of, as I said, performance improvement. I will not go into it because we don't have a lot of time. I do want to leave some time for ISOs. So this is taking from ISO Summit that we took place in Coke, and we actually found the street name, which is nice. So let's look at the direction for ISO from storage highlights perspective. Volume replication, you heard that in a previous session, so I won't go deep into that. We have the multi-attach, the ability to attach a single volume to different hosts, right? Also another increased functionality. Volume retap, I want to change the type of the volume, it was not there before. So things that may look to you trivial are not necessarily implemented yet. So we're taking access links. Actually, it's important stuff. We talked about security before, being able to change different permissions. You can have reads, she can have writes, etc., etc. Depends on the tree of in the organization. Important feature: volume export import. I have an existing or a deleted, right, marked for deletion volume. I want to actually be able to import it back. Some of this vendors actually, like VMware, would like to take from the different environments and bring it into OpenStack, etc. This is what this feature is all about. Bare metal, you heard before the discussion in the morning. Bare metal volumes, of course, is part of it. Public volumes actually multi-tenant. I would like to take a volume that was in one tenant and make it available in another tenant. Also was not there, public need and the public clouds, of course. And of course, notification. This is more for usage of Ceilometer. So I want to know if someone attached the volume, know on when it was done. Filter weighting is also an important one we touched. It's basically the continuous work around the filter to take a better decision making when it comes to leveraging the backend storage. Glance, image recover. I would like to recover an image that was not properly imported. This is one of the use cases. Other use cases is basically I took it from another environment. I want to make use of it. Basic fundamental things. Import, export from the HTTP. Finally, going to be part of Icehouse and other multi-location features. We're going to finish with Swift. Swift policy is part of the overall, I will call it, improved object replication in Swift. And I would just want to make a point to the third one, which is the pluggable backend API. So far for Swift, as you know, was the object storage. Today you can actually leverage Gluster as a backend and actually save some copies and get a better performance and actually utilize Gluster features as well. Red Hat invested in this upstream, and of course Ceph is just last week announced that they're going to make use of it and they support it as well. As I said, object replicator replacement for rsync. This is something not necessarily will go in, but started to work on. Searchable metadata, also driven by IBM and HP.
Sorry? What is that thing?
Async is basically it's an alternative way to do rsync. Okay, we're looking at, in general, most of the problems you see in the Swift are scale, right? I need to be able to, if we shroud the large containers, for example, it used to be one container for one account. It's no longer the case. If you have billions of records, you need to be able to scale it, and we're looking at better ways to manage it. That's it. So thank you for joining the session. This presentation will be online, and I encourage all of you basically to look at the release notes on Havana and start using these features. I will be taking questions. I think we have a couple of minutes. Go ahead.
One of the features that are missing today in the storage, and it's also missing now when we have a Savannah for Hadoop, is the ability to execute compute tasks on storage. This will benefit the Hadoop principle when everything.
And do you see it part of the Savannah work, or do you?
No, it could not be. Savannah is a management.
Yeah, I know.
So it has to be part of the storage.
Have you opened the blueprint for it already?
For this one already?
Yes.
You mentioned quotas.
Yes.
So how deep quotas integrated with metering and multi-tenancy?
Excellent question. I think it's all
What's the question again?
quotas and metering. As I said earlier, OpenStack is all about top-down, right? We need to be able to allow users and administrators to do things all the way down. In a sense, some of the times you'll see in Cinder will do the infrastructure, Nova will do the scheduling, right? You'll see, here we saw that also taking place in grants. So it's not just one project. Some of the features are spanning across the whole projects, but we need maybe the heavy lifting to be done in one project, such as Nova as enabler, and then we'll continue to do the rest to support it. This is one of them. So I think by in Havana we already have a good quota management. Again, it's not complete. So there's the basic functionality, there's advanced management, and it's all about the tweaking of basically what the user would like to see, right? It's not just being able to control it as administrator and have all the notifications, et cetera, metering, for example, and chargeback and SLA, but also what do you provide in terms of user functionality? Because if I'm the user, I would like to manage my own data, et cetera. So it's two separate needs that need to be dealt with. Other question? Find a question. Not you, someone else, maybe? I mean, you're the key. Okay, if no one else, it's yours.
Thank you.
A quick question.
So,
Quick one.
okay, today VM's or instance data is on a host. It's problematic when host is going down. Instance is terminated, there is no data of the instance. Ability.
Are you talking about the metadata?
No, the data, the instance data. So
it's one way to implement. You do have Cinder that you can use block storage or whatever. So
using the entire instance from Cinder.
Boot from volume.
Thank you.
All right. Thank you all.
Thank you all.
Thank you.